Vectors, page 14. So we have the position vector OA and OB, and we're going to find the vector AB and then find the distance from A to B. Okay, so to find the vector AB, we're going to take OB, which is 1, 3, negative 1, and we're going to subtract OA, which is negative 2, negative 1, 1. So that would be equal to 1 minus negative 2 is 3. 3 minus a negative 1 is 4, and negative 1 minus 1 is negative 2. So that's equal to AB. And then what about the distance from A to B? So we could find that with Pythagorean's theorem, 3 squared plus 4 squared plus 2 squared, which is equal to 9 plus 16 plus 4, which is, I think, 29, square root of 29. I think that's right. Okay. Next one, 5. If A is vector A is 1, 0, 3, and vector B is negative 2, 1, 1, find the length of vector A. So that would just be the square root of 1 plus 9, 3 squared, which is 9. So that would be square root of 10. Let's see, C would be 2 times the length of vector A, which would be 2 square root of 10. Negative 3 times the length of B, so let's find the length of B first. It's equal to square root of 4 plus 1 plus 1, which is 6, square root of 6. And so it's negative 3 times square root of 6. So that would be yeah, that would be the answer right there. Okay. Okay, and now vector A plus B, find the size of that, or find the distance of that. So first you'd have to do A plus B. And to find A plus B, it would be, let's see, you would add the x vector together, the x coordinates together, which would be negative 1. You'd add the second dimension together, which is 1, and the third dimension together, which would be 4. And then you would take the length of that, so it would be 1 squared plus 1 squared plus 4 squared, so that would be equal to, I think, square root of 18. Okay? Number 7, consider the points 2, 1, negative 2, 0, 3, negative 4, 1, negative 2, 1, and negative 2, negative 3, 2. Deduce that BD is equal to 2AC. Well, let's see. Let's find BD first of all. So BD would be negative 2, negative 3, 2. And then B would be 0, 3, negative 4. So if we subtract those, we get negative 2. Negative 3 minus 3 is negative 6. And 2 minus negative 4 is equal to 6. Okay, so that would be BD. What about AC? What does it look like? So AC would be the C point minus the A point. So that would be 1 minus 2 would be negative 1. Negative 1 minus 1 is negative 3. 1 minus a negative 2 is 3. Okay, so, and if we multiply that by 2, then we're going to get, hey, we're going to get negative 2, negative 6, and 6. So it works. All right. Use vectors to determine whether ABCD is a parallelogram. ABCD. Okay, so this is kind of like the problem we did on the last page. If we have ABCD, then there's a couple ways we could do that. Maybe the easiest way is to do what they asked us to verify at the end, where we said, hey, take the midpoints of the two diagonals and see if they're the same. And if they are, that means that it's a parallelogram. So why don't we do that? So we'll take the midpoints of AC, and we'll take the midpoint of BD. And if we get the same number, the same coordinates, then we'll say it's okay. So like, for example, AC, the midpoint would be halfway between 3 and negative 1, which is 0.5, I think. No, it's not. Halfway between 3 and negative 1 is 1. And then halfway between negative 1 and 4 is also 1. Okay. What about between b and d? Halfway between 4 and negative 2 is 2. And halfway between 2 and 1 is 1.5. So, no, not a parallelogram. Okay? Because the midpoints are not the same. Okay, let's try to do with C the same thing. So, let's see. Between A and C, the midpoint between A and C would be between 2 and negative 2, it's 0. Between negative 3 and 6, the halfway point would be, let's see, 1.5. Is that right? Maybe. And then the z coordinate, 2 and negative 2, it would be 0. Okay, let's try to do B and D now. Halfway between 1 and negative 1 is 0. Halfway between 4 and negative 1 is, let's see, 2.5, 1.5. And then halfway between negative 1 and 2 would be 0.5. 0.5, right? So those also no, right? Almost. Very close. Just the z-coordinate was off. All right. Moving on. In the given figure, BD is parallel to OA. BD is parallel to OA. Okay. And half its length. Find in terms of A, vector A and B, vector expressions for B, vector BD, vector BA, and vector AD. Okay, so we're going to find in terms of A and B. Okay, so in terms of A and B. All right, so BD, vector BD. Well, they already said the vector BD is parallel to OA and it's half its length. So we could say it's equal to 1/2 A. Okay. What about vector BA? Vector BA. Vector BA is this diagonal here. Vector BA. So we could get vector BA by combining vector B and vector A, right? So we could do a negative of vector B, because that would put us there. And then we could do positive vector A. What about vector AD? Vector AD is this vector there, AD. So we could use vector, let's see, vector B. Let's say we could do a reverse of vector A. Then we could do vector B. And then we could do half of vector A. Okay, that would be AD. All right. Next one, 13. For vector A is equal to 2, negative 1, 1, B is 1, 2, negative 3, and C is 0, 1, negative 3, find A plus B. So A plus B, we would just add those two together. So 2 plus 1 is 3, negative 1 plus 2 is 1, 1 minus 3 is negative 2. Okay. What about B plus 2C? B plus 2C. Well, let's find 2C first. 2C would be 0, 2, negative 6. And B is just 1, 2, negative 3. We're going to add those two together. So we get 1, 4, and the last one is negative 9. Okay. Now vector A minus vector B minus vector C. So that would be 2, negative 1, 1. And minus B would be, I'm going to write it as an addition. Negative 1, negative 2, positive 3. And then minus C would be 0, negative 1, plus 3. Now I'm just going to add everything together. It's a little easier to add than to subtract. So 2 minus 1, 0 is 1. Negative 1 minus 2 minus 1 is negative 4. 1 plus 3 is 7. Okay? 1, negative 4, 7. All right, now find the scalars A, B, C. So you just multiply these out and equate them. So it's like 2 is equal to B, 0 is equal to C minus 1, and 6A is equal to 2. So we already have B is equal to 2, C is equal to 1, right? And A is equal to 1 third, or 2 over 6, right? That wasn't too difficult. What about this one? We have 2a plus b is equal to 7. We have negative 3a plus 7b is equal to negative 19. And we have a plus 2b is equal to 2. And we're supposed to figure out what a and b are equal to. Wow. Well, this is one more equation than we actually need, because if you have two equations and two unknowns, you can already solve it. So let's just do that. We'll assume that there is a solution, and we'll find it. So from the bottom equation, we get a equals 2 minus 2b, and then we're going to substitute in that equation. So we get 2 times 2 minus 2b plus b is equal to 7. So 4 minus 4b plus b is equal to 7. So 4 minus 3b is equal to 7. So negative 3b is equal to 7 minus 4, which is 3. So b is equal to negative 1. Okay, so b is equal to negative 1. So if we know that b is equal to negative 1, then we know that a equals equal to 2 minus 2 times negative 1, which is 2 plus 2 is equal to 4. So a is equal to 4, b is equal to negative 1. And we can test that to make sure that this middle one that we didn't use works. We can put negative 3 times 4 is negative 12 plus 7b, which is negative 7. Negative 12 minus 7, and that's equal to negative 19, so it worked out. Okay, and that was page 14.